All right. Hello, everybody, and thank you for joining us today in this installment of our NDB Tech Talks. We're very happy to have you join us. My name is Mohammed Karam. I'm from the product management team on NDB, the Nutanix database service. And joining me today will be Daljit Singh, who is a staff database engineer on the NDB team. Him and I will be tag teaming for emceeing this event today. So we'll start off with a couple of housekeeping items. First of all, we just wanted to make sure that we can tailor this content in a way that is most appropriate for the audience and your level of expertise with using NDB. So we'll be kicking off with a couple of questions in a poll in a second. And the other housekeeping item that I wanted to share was we would love to get your questions. So please make sure you send those to us in the questions channel rather than just the normal chat conversation. It'll help us from an NC perspective figure out how to react to them most appropriately. And with those housekeeping items, actually, we should be getting ready to start. So again, remember the questions button, and let's move on to the poll. I see lots of familiar names. Welcome, everybody. If you're just joining, you should be getting a couple of questions on the poll. So please help us by responding to those. We'll give folks a few seconds to give us their responses there. Right, and I guess with those responses coming in, we'll probably give folks a few more seconds, and then we'll be ready to get started. Garrett, let's call it 10 seconds, and then we can move on. Perfect. All right. Okay, so Daljit, lots of interesting responses here. We see people are predominantly on more recent versions of NDB, so thank you for proactively being there with us. And right, yeah, a familiar mix of database engines. Perfect. Okay, that's we can work with that. Definitely something we can use there. Perfect. So thank you for giving us that information. Really quickly, to make sure that if anybody doesn't have experience using NDB, we'll quickly go through the slide that may be familiar to most people who are already on NDB. But basically, just a quick introduction. What is NDB? It is a service that allows you to get very comprehensive functionality for automating your database engine management with lifecycle management and many different key features that help the day-to-day on your database management orchestration and usage. Basically, it runs predominantly on premises with hybrid support as well. So you can run your VMs in over AWS and Azure. And once you do that, there's several database engines that are supported. You can use SQL Server or Oracle or MySQL, Postgres with EDB as well, or some vector support, some for plugins, including the vector support. We also support MongoDB and MariaDB. The lifecycle management that we provide and the additional features that can be facilitated with NDB are one that we're going to build on today. Specifically, provisioning of single instance and high availability databases that we're going to talk about at length. With this underlying architecture, you also get very effective thin cloning as well as very effective backups and recovery. You also get storage scaling that is managed by NDB itself, as well as intelligent scheduling for patching and security features as well. With that background, I think we're also ready to move into the actual conversation today, which gives us a chance to introduce or level set the conversation about high availability for the database space. High availability overall from a everyday language perspective, as well as from a tooling perspective, can mean different things to different people. So it's important for us to take a moment to make sure that we are aligned on the definition as well as some of the tooling that we're going to be using. So from from our perspective as NDB, we take a pretty canonical interpretation of what HA actually means, and from a level setting perspective, it's basically a key part of your business continuity planning strategy. And if done properly and under ideal conditions, it basically allows you to hit very effective near zero recovery time objectives and targeting zero recovery point objectives. Your recovery time objective, or RTO, is basically how long your business can afford to be down before service is restored to that specific tier of applications. Again, similarly, the recovery point objective, or RPO, is how much data the business can afford or tolerate to lose in the event of a fault, again, for a specific tier of applications. With high availability, as designed, basically what happens is you can get near zero or imperceptible impact. The reason why we're highlighting the fact that it's near zero is because in the event of a fault, there will be some time that elapses until a fault is detected, but the systems can be optimized in such a way that, coupled with a robustly coded application, basically the entire experience can be impervious to the fault with solid retries and so on. Effectively, the impact is imperceptible to the applications and the users. From an RPO perspective, again, one thing we're going to drill down a little bit deeper in the next couple of slides is you are relying on synchronous replication. Because with an HA design, with an HA topology, you have very low internode latency by design. And therefore, even if something happens to one of your nodes, you're expecting a synchronous copy of the data to exist somewhere else, which is how you are able to hit that zero RPO target. Again, under ideal circumstances, if a limited number of failures are being sustained, and so on. Perfect. Now, so with that defined, the next thing we'd like to sort of focus on is how is this concept of high availability distinct from disaster recovery, or DR? And again, from a vernacular and tooling perspective, what ends up happening is that sometimes the line gets blurred. Sometimes people can use DR tooling for HA purposes and vice versa. So it's important to take a quick moment to make sure that we're comfortable with what that boundary looks like, and use that to define how we're going to scope today's conversation. In essence, it all boils down to the kind of replication that you need, that you're going to be able to use. For high availability, you absolutely have to have synchronous replication. Whereas with disaster recovery, you can basically operate with asynchronous replication, where you're acknowledging a write and sending that information over to different nodes on your network without having to wait for them to sort of acknowledge that notification synchronously. That's the key thing it boils down to. If you look at this from a parametric perspective and you compare between both high availability and disaster recovery, what you see is the following. Because of this constraint, usually you get a high availability cluster deployed within a very close proximity to each other, to its own constituents. So it's in the same data center or within data centers that are very closely situated in the same metropolitan area, for example. And you get, by virtue of that, extremely low latency, so less than 10 milliseconds, which then allows you to configure your cluster in a synchronous manner. If the latency gets higher than that, then having synchronous replication becomes a performance burden, and it's not always possible. So again, that's one of the things that you design for with high availability. And as we said previously, this then allows you to have a zero target RPO and near zero RTO. And when you have all these things in place, when a failure event happens, you can, in fact, rely on automated failover, because you've designed everything in place that it's ready to just transparently switch over to another node. Conversely, if you compare this to disaster recovery, by design, you need your disaster recovery data center to be geographically distant from the first data center, so that, you know, if a disaster hits that one, the second one should hopefully be safe enough and distant enough from that disaster so that it will not be impacted. By virtue of that distance, you will probably incur higher latency. You may not be able to get synchronous replication. You'll have to contend with asynchronous replication, and therefore your RPOs and RTOs will be larger than zero. Once you get RPOs of larger than zero, you may sustain data loss in the event of a disaster, which is why in many events, or in many cases, disaster recovery failover has to be a very deliberate evaluation of the pros and cons of conceding that there is data loss and moving your data center from one location to the other, by virtue of having decided that, yes, you know, this first data center is no longer available, so we need to move on and acknowledge the data loss and take the hit and move on. So again, that's what it boils down to. Again, very briefly, in a nutshell, HA gives you intra-site failover, and disaster recovery gives you inter-site recovery. Quick note about disaster recovery, specifically, you can pursue disaster recovery, again, by virtue of that leeway that you have with RPO and RTO, via several different mechanisms. You can have native database tooling, which is, you know, the most advanced way of doing this, with transaction awareness, and can give you some of the most effective RPO and RTO targets. Or you can do it with regular backup restore based recovery. And you can also use infrastructure based recovery, where you have images or VMs that you rely on that are relatively updated, or other mechanisms. So there's many ways of doing that, according to your requirements. Ultimately, though, for full sort of business continuity planning, depending on the criticality of your applications, you need to look at both, because they serve different purposes, both HA and DR. Again, for today, our focus for today's topic is specifically for high availability. All right, with that in mind, let's move on and discuss some of the key concepts that let high availability run. And we're also going to look at sort of how they differ somewhat and also substantially between different database engines. So the first thing that you need to establish, to prepare for high availability is making sure that you're ready for a majority-based or a quorum-based leader election. So you have a bunch of nodes that are participating in an HA cluster. You need to be able to plan that cluster size in a way that allows you to delineate clearly what the minimum number of nodes that will have to agree among them in the case of a network outage or some other failure, who the leader or the new leader should be. So that number is a key part of your cluster design. When you have that number, basically, they are able to collectively communicate with each other to decide that it's safe to keep running without incurring a split brain scenario. What is a split brain scenario? Again, really quickly, it's basically when different parts of your cluster are disconnected, but then if it's not designed properly, each part of that cluster may incorrectly think that they are the remaining leaders. If that happens, then you can start getting changes on different ends of your cluster, leading to conflicting changes. That's why this concept of majority quorum is very important, because it allows you to avoid that split brain altogether. Now, fundamentally, all HA implementations are based on some variant of this implementation, but it's implemented differently in different databases. One interesting example is Oracle, which implements quorum via its own layer of underlying architecture. So they have this implemented in their clusterware, as well as via file system-based quorum monitoring, which then bubbles up to the user of a rack cluster as transparently as a decision about which node they should be communicating with. So that's the situation that you get with Oracle. Another couple of examples that sort of are much more visible in how they do this would be Postgres and MySQL, where it's very clear how they manage their quorum. For example, with Postgres, when you roll out your database, you deliberately add components like Patroni and etcd on each and every single node, and the etcd network then starts the health monitoring, which then leads into the quorum-based election process. And MySQL has a very similar setup as well. Now, all these differences, they can get kind of intricate, even though the fundamental theory is similar. But again, one of the things that sort of NDB helps in this case is that it abstracts all these differences in a way that lets you as a user focus on the outcome, which is, guys, I just need an HA cluster, rather than having to figure out how each specific database engine operates differently from the others. So that's a primer about the key way that DBHA topologies work. Now let's look a little bit deeper at how NDB makes this even more straightforward for you as a user in a really game-changing way. As we hinted at earlier, there's several challenges of implementing HA like on your database engine directly without the assistance of any additional helpers or tools. First of all, what I just explained is it's not straightforward. It's kind of complex. There's various topologies that you need to manage, and each topology has different configuration knobs. So you need to be on top of that. Make sure that you're doing this again repeatedly for each single HA instance that you provision. And not only that, but as we said earlier, this differs across different database engines. So you need to make sure that you're alert and aware of how all these differences compare to each other, especially if your plan is to manage these in a long-term manner in a semi-coherent way. What happens is your different setups will diverge, and you get a fleet that is fragmented and not necessarily uniform. NDB jumps in here, and all of a sudden, again, you get the database engine specifics abstracted behind a common layer of API CLI for your automations, as well as the user interface, if you wanted to do this via the GUI. And the way this happens is it leverages standard profiles for software, for networking, for compute, and it leverages standardized topologies that just are implemented and stamped every time you want a specific HA deployment to be available. So immediately that prevents configuration sprawl and makes your life managing them over the longer term much, much easier. It does this also while bringing together the features that I was discussing earlier about, it gives you time machine for point-in-time recovery, and it gives you the ability to automate your workflows and tight integration with LCM operations, especially in this case with HA. The lifecycle management operations are HA aware, so you can start implementing rolling patching. NDB knows that this is a cluster of collected nodes, so it will manage the patching operation in a schedule where it moves across the different nodes individually, so that you'll always be able to have a node up and running, and your HA cluster continues unimpeded. Similarly for backups, it is aware of what happens with the HA server roles. So if a primary is changed and a new primary is elected, NDB knows which one that is, and it will follow that new node for the remaining backup chain. So that's just a few examples, but again, I think that's the tip of the iceberg. Folks on NDB know that you're basically running on top of the Nutanix stack, and that automatically gives you many additional resiliency features off the bat, even for a single instance implementation, which we'll walk through in a moment. But it basically comes down to intelligent VM host affinity management that works in tandem with the intelligent storage platform provided by the Nutanix stack. So I'll give you a little bit more detail about what these look like in a moment. Basically, yes, it's enhanced data resiliency because of inherent replication that happens at the storage layer, and intelligent VM host affinity optimizations. So what does this actually look like? Let's talk about the data resiliency first. We've got a quick illustration here based on two different models that you can use with the underlying storage stack. Basically, there is you can use replication factors. There's two different variants. There is RF2, where you get two different copies of the data being maintained, and there's RF3, where you have three. So let's monitor a specific write IO operation that is issued from a VM and is it's running on RF2. So it will store one copy of that write message on one node, and that is the most local node to it. But another node will be kept in a nearby or more distant storage node as well. So if anything happens to your storage layer, that can be rescued and healed automatically. So that's entirely transparent to you when you're using RF2. Similarly, with RF3, the same thing happens, but across three nodes. So your tolerance for failure is for up to two of your storage media, while the third one will still be available, and the underlying system will automatically take care of the healing and the healing process in this case. So that's how the replication factor helps in this case. The other thing that you get also with a high availability cluster is when you provision this with NDB, NDB knows that the virtual machines that you're provisioning right now are associated with a specific HA cluster. And by virtue of that, it will do a few things. First of all, it will make sure that it needs that we have the minimum number of physical hosts required to host that number of virtual machines. So as we were talking about the quorum earlier, and we can get into a little bit more detail about this if we have time later on. But folks who are familiar with the majority quorum based leader election will remember a few things that include, for example, the fact that you are, as a best practice, you need to be able to use an odd number of nodes in your HA cluster. And it really only begins to make sense starting with 3 nodes. So let's say that we want to deploy that minimum viable stamp. So we're going to have a 3 VM footprint. So for the NDB HA allocation algorithm, automatically the system knows that it needs to map these to 3 different hosts, physical hosts. And if those 3 physical hosts are not available at the time of provisioning, you are alerted to this so that you can then go ahead and avail more physical hosts either at the time or shortly thereafter. But basically, this happens from the get-go. If it does find 3 available physical hosts with enough capacity at the time of provisioning, it will deliberately affinitize those VMs to different hosts. The reason why this is important is if, let's say, this had not happened, and let's say that VM1 and VM2 were randomly, they just happened to be associated or hosted on physical host 2, and then you get an outage on physical host 2, that would have taken down 2 VMs immediately, which, this being a 3-node cluster, would compromise your majority quorum because you've just lost 2 nodes out of 3, so there's no way you can hit quorum anymore. Now, with a deliberate VM affinitization and anti-affinitization, you avoid this problem. Basically, you have a tolerance for incremental levels of failure. So if you get that affinitization set up properly from the get-go, and you have any one of these hosts, again, let's pick on host 2, failing, that's okay, because VM2 is the only one that you've lost. And in the interim, operations will continue running between VM1 and VM3, while a rescue operation happens for VM2 and it then begins to live on, let's say, host 1, for instance. In this case, so you have your full capacity and you have your HA unimpacted. This is an interesting scenario, though, because you no longer have 3 physical hosts, which means that you're running at somewhat of a degraded tolerance for future failures. So if you're lucky and then host 3 fails, again, your HA cluster is unimpacted. But obviously, in this case, you do not want to accommodate host 1 itself failing. So that's basically how the failure cascade happens, and that's how it is managed intelligently by having a minimum number of physical hosts. So that schematic shows you a couple of possible scenarios that go through there. But in reality, what happens is you will not have 3 physical hosts in a specific deployment. You may have significantly more. And when that is the case, NDB will continue fanning out those VMs across different physical hosts, so you continue having that resiliency for as long as possible until those failures are managed. All right, so that's just a really brief summary and an intro into this space. Hopefully that's whetted people's appetite to move forward and also explain how the underlying stack, the technology stack, and the underlying infrastructure helps boost availability and reliability off the bat. With that said, I think we're actually ready to move into a demo where Daljit will be able to show us how some of these things work on the actual system. So Daljit, I'm actually going to stop sharing now, and you take it away.
Thank you, Mohammed. Let me share my screen real quick. All right. All right. Can you guys see my screen?
We can.
Okay. Hey, hello, everyone. So this is the NDB console, the NDB interface, for those who are not on the NDB platform yet, so I just want to show that, this is what the NDB console looks like. And, once you log into that, what you see here is like the overall picture of your deployment. It just tells you about your databases and your alerts and things like that, which you have configured in NDB. So there are different tabs which you can roam around. So if you go to databases, it tells you like, what it shows the overall widgets of all the databases which you have configured and provisioned through this NDB console. And in this demo today, we are going to cover deployment of a Postgres HA environment. So if we go to the provisioning tab here. So it basically gives you the option to provision all these database options here. So like you can do Oracle, single instance, and RAG SQL Server same way, Postgres, then Mongo and Maria and MySQL as well. So like I said, today we are going to cover the Postgres HA. So we're going to provision a HA instance. So the first screen over here is basically is showing you basically all the servers which you got configured, the clusters which you got configured with NDB and where you want to deploy this Postgres HA environment. So in this case, I'm just gonna name this as a demo and we can call it a demo environment. We can pick multiple clusters. So what it means is like my PGHA will be deployed across 2 different clusters, in this case, Tomahawk and Console. So then we select a network profile, which provides the IPs and all to the VMs. It's basically spanned across these 2 clusters, which will give me all the IPs for my VMs here. When we click next, so here we have the software profile page where we need to select like which software profile we want to use for this deployment. So software profile is basically your database versions and it's like an image of your database, right? It's like it has your OS and it has your software disks installed into that image, and we want to use that image for this deployment. So in this example, like we can see, we have like 2 of those images here. So 2 of the software profiles here. So I pick one of them, and it's a compute profile, which shows like, like how big of your compute instance you want for this deployment. So for this, let's pick medium. And here is the credential page where what it means here is that when you have the image, right, it already have your NDB drive users and it already has some passwords and the SSH certificates and whatnot, right? But if you want to change that on your deployment, so let's say you have an image where it has some password, but now for your deployment you want to change that password. So you can definitely do that, and it will override that password here. Or you can do the same thing for the SSH public key as well. Like if you want to use a specific key for this deployment, you can upload that as well here. And this section here describes your database server VMs, which are going to be part of the Postgres HA deployment. So by default, like, it starts with 3, and definitely, you can add more or remove some of the instances. If you have 5, you want to go back to 3, you can remove, you can add, and you can basically configure the number of nodes for your HA deployment accordingly. And it also gives you the option to spread those VMs across those clusters which you have selected. So remember on the previous page, we selected 2 of the Nutanix clusters. So in this deployment, 2 of the VM will live on Tomahawk and 1 of the VM will live on console. We click next. So for the PGHA with the NDB, we use Postgres and Petroni and etcd as a technology stack to basically configure the HA. And what this tab is basically is about the Petroni cluster thing, right? So Petroni cluster, when we configure, it has its own cluster name. So this gives you the option to define a customized cluster name as well. So we can say demo cluster. And we also have HA proxies. We do support HA proxy. So what it means, and it's an optional component, like you can see, if you don't want HA proxy, you can disable that. But if you want HA proxy, you can enable this radio button here, and then it will give you all the options for the HA proxy as well. So what HA proxy does is basically it works as a load balancer for your HA deployment, right? So this becomes the entry point of your client connections, and your client, you can redirect all of your traffic of, your read-write traffic versus your read-only traffic through these ports. And the client will basically make a connection to the HA proxy using these ports, and the connection will be redirected to the database server VMs, according to the role which you have, or according to the port you have selected. And the other component here is the virtual IP. So what this does is basically, like you can see here, the HA proxy is also deployed in a HA fashion. So what it means is, like, we are deploying 2 different HA proxies. And in order to basically to reach to these HA proxy VMs, we have a virtual IP also. So what this virtual IP does is, it's going to have a virtual IP which is going to be tied to one of these VMs at any given point. And if this VM fails, so then the virtual IP will fail over to the other one. So this virtual IP will become your entry point basically. And then for a client connection, the client will use a virtual IP and then any given port. Like if it is an application which does read and write, so they will use 5,000 port, and the HA proxy will redirect the connection to the primary node. Like at that time, whichever node is the primary, the connection will be redirected to that. And if it is a reporting application and it uses the VIP and the port 5001, so it means it's only need the read-only access. So the connection will be redirected to a synchronous or an async replication, depending on the environment, right? Like what you got. So here are the database server VM roles. So we can define, like at a time of provisioning, which node I want to be primary. So here, like my demo 1 is going to be primary, and the auto failover is the other option here, which defines if this is going to be part of the auto failover or not. What it means is, like, if my primary goes down, can demo 2 can become primary or not. So that is the auto failover feature. So if you don't want any one of the VM or any VM not to participate in the leader election, then you can just uncheck that. So that means that the demo 3 will never become the leader. But in this case, let's keep it on. And the other option here is the enable sync replication. So that's also an optional component here. So what it means is, like, you can either deploy a PGHA cluster with 1 primary, 1 sync, and 1 async, or you can have 1 primary and both of them as async. And then if you uncheck this, so it means, both of these nodes will become async replication, right? It will work as async with the asynchronous replication topology. But if you do enable synchronous, so it means out of these 2 replicas, only one will be the synchronous and the other will be the async. So let's keep it that way. If we say next, so here is the Postgres instance information. So this is the instance name which you will see in the NDB console as well. So we're going to call it demo, and again, demo PG instance is the description. And this is the actual Postgres ports which we want to use, and the listening port of the Postgres. If you want to, this is the default. If you want to change it, you can change it. This is the size of the database which we want to configure. So definitely, when we do the provisioning, this database is going to be an empty database. But what this means is, this is the amount of the disk space you want to attach to the VM, for your initial database. So let's say if you have a job right after the provisioning, you want to, do some batch load, and you want a database to be a specific size, you can define that size here, and that kind of disk will be attached for with the VM to support that kind of database. And again, this is all going to be thin provisioning, so it's going to attach this disk, and it doesn't mean that from the storage pool we are going to take all the space right away. Name of the initial database, if you want to have some custom database names, to be in there as part of the deployment, apart from all the default databases which Postgres comes with. So this is the database, it will add as part of the deployment. The database parameter profile, it's a profile basically which contains all the parameters for the Postgres instance, like what goes in the Postgres.conf. So we have different profiles here, and depending on the requirement, we can have different parameter profiles. So I'm just going to keep the OLTP one here. So this is a database user. It's basically the owner of the Postgres binaries who will own the Postgres database software on the VM. So if like most of the time we're going to use Postgres, but if you have a custom requirement or not to run Postgres as Postgres user, you can change that over here as well. And then the password for that user as well. So I'm going to keep that. So here we also have some options for pre and post commands. So, if you have any custom jobs you want to run before creating these instances, you can attach those over here. You can attach a shell script or a shell command, and it will basically, the provisioning workflow will take care of that. And it will basically, run this script or command as per the action you define, like pre or post. So we're going to leave it as is. And this is the time machine section. And in the time machine section, for those who don't know about time machine, it's basically your backup mechanism, like how you're gonna make the backups and keep the log catch-ups and the snapshots of this PGHA environment. So I'm gonna name it demo_TM, which is the time machine, and we can call it demo time machine as a description. And we have certain SLAs as well, right? So depending on your requirement, whether it's like your testing environment, production environment, you can create new SLAs and you can define your backup policies as per these SLAs. And once you define that, the backup will run as per the given SLA. And here is the schedule where you define like when you want to run a specific operation. Like for this SLA, for example, the daily snapshot will occur at 22. And we have like snapshots per day, one log catch up every 30 minutes. If you want more, if it's like a production environment, you want to do more frequent log catch ups, you can do 15 minutes also. And log catch ups means the transaction log backups, right? So how frequently you want to run this thing. So if it is like a dev QA environment, you really don't care about the data, you can have more relaxed SLA of like 60 minutes or something. So let's go to the next screen. And this screen basically gives you the option for some of the advanced options to configure some of the advanced options with the Postgres. So for example, encryption is one of them. So we do support TDE. And if we go this route, then the database will get encrypted using the native TDE method. And we also have some patching options, right? So it means if you want to do some operating system patchings, database patchings, you can enable all those right at the time of provisioning. This can be done later as well, but at the time of provisioning also you can define your maintenance window, and then you can define whether you want to run operating system patches through NDB or not, right? And if we see some of the advanced options, so same thing here, like before running these patches. So for example, if I'm doing the operating system patches, so these are the pre and these and the post scripts basically, right? So like right before running the patch, if you want to do something, or right after running the patch, if you want to do something, so you can define all those. The NDB provides all the hooks to you for all these options. So once you provide all these things, the workflow will take care of that, and while running the patching, it will run these commands or the scripts as well. So these are the tags. Like it's basically for your NDB repository maintenance, right? If you want to tag the entities and group them with the tag or things like that. So I'm just going to call this as a demo entity. And before I click the provision button, I also want to show you this thing here. It says API equivalent. So what it means is we are trying to do the provisioning through the NDB console, which is a GUI option. But we also support the API and the command line interfaces as well, right? So we can go through this console, and at the very end, before running the provisioning, it can give us the payload for the API as well. So we can download this payload, and we can use this with our automation scripts, if we have any. And we can just keep modifying this, the value of the profile IDs, the name, etc. Whatever we got, and we can just we can use this API payload to do the to do the automations of the Postgres provisioning workflows. It gives you the different options, different themes, like how you want to, like in which format you want to download it. And so for this demo, we're just going to stick to the GUI option. So when I click provision, so now it says, okay, my operation has been submitted, for the provisioning. So here we can see, when we go to the operation tab, we can see that a new operation has been submitted, and this is the provisioning database operation. And if we go to the bottom, we can see all the steps which it's going to do and what it's doing here, right? So right now, like, you can see it's done with the pre-processing. It pulled all the profile information which we provided, and it's creating the virtual machines. It's like 3 of the virtual machines here it's going to create. And these are the steps it's going to complete. So once it's done with all that, it's going to take a couple of minutes. We will have a PGHA environment with the 3 Postgres nodes and 2 HA proxy nodes with 1 VIP. So it's going to take a couple of minutes, but what we can do is I can just real quickly show you one of the environment here, which I have provisioned earlier. So once the database provisioning is done, you can go to the database page, and on the database page, it will show you all this information about the environment. So like here, you can see the status is green, name is test, and the database version, the size, and when it was provisioned, some of the alerts which got created from the NDB. And these are the database server instances, the DB VMs, the actual DB VMs, and it tells you which one is primary, which is the source of backup, and it has all the database tabs as well, right? So it shows like what all databases are there. If you want to add more databases, we can do that from here, and we can also remove a database from here, And this is the profile information. It just gives you the overall picture of how your instance looks like. And this is the important one, which is the time machine, which is associated with this HA environment. So if I click on the time machine, it shows my SLAs and what all we got for as far as the recovery perspective goes for this environment. So you can see here it shows a nice timeline. This database was provisioned like a couple of days back. So all this green area is basically your recovery window. So it shows that the time machine has the capability to do a PITR for any of these given points. So I can restore my entire environment to any of this given point as per the recovery window, which is defined here. So what it means is like it's doing the log catch-up, it's doing the transaction log backup every 15 or 30 minutes, and it's backing up all the transaction logs and have a continuity of all the logs to do a PITR to any given point. So if I want to go back to like 23, this is a provisioning time, I can restore even up to that time, So that's the continuity. So it shows like it gives like a clear and neat visual interface to see your recoverability options for the database. And with that, that's all I got for the demo. Mohammed, you want to continue from here?
Perfect. Thank you, Daljit. Give me 1 second to project my screen once again. Yep, ready to when you are. Perfect. When you stop the sharing from your end, Daljit, I will project.
Yes, doing that.
All right. So first of all, thank you for walking us through that. Again, very interesting as always. And folks, what Daljit just showed you also happens to be available on our demo site, which is demo.nutanix.com. I will show you that link momentarily as well. I'll flash it on the screen. But really, there's a few additional highlights I wanted to add, as well as get to people's questions. So just 1 second, let me show you the URL once again, and there we go. So yeah, demo.nutanix.com. Actually, I invite everybody who hasn't used NDB, or even if you have, to jump onto demo.nutanix.com, and you can select NDB from there. It'll show you the exact same capabilities that Daljit was walking us through a few moments ago. Now, the interesting thing about demo.nutanix.com is it's basically it's a front-end system. It's not a real hosted system. If you need a hosted test drive, we can also arrange that. There's multiple mechanisms of getting one. There's a test drive and there's hosted environments. So please do connect with your account manager, and we can patch you up with those as well. Demo is one of my favorite entry points, though, because it's very convenient and yeah, it's accessible. Like you just jump onto the URL and you can set up an account in no time. To answer some of the questions that we were getting over the call, there was one which I wanted to start with actually because it had to do with how the system was operating. Basically, demo.nutanix.com specifically reflects the most recent version of NDB released. So at the time of this talk, it's going to be 2.8. But as early as sometime next week, you should also be able to see 2.9 on that live. So that's a system that you're going to be able to test drive on demo.nutanix.com then. So you'll see basically the newer features that are coming in with 2.9. Speaking of newer features, one of the questions that are related to this is from Arindam, where he was asking about is TDE for Postgres a native feature now in NDB? And yes, you will see this support coming in as part of your provisioning, and you can also do this from the UI and API CLI. As Daljit illustrated, it wasn't the key thing we wanted to highlight as part of the provisioning, but then the provisioning workflow takes you through all the different options. So yes, that's a good call out there. Well spotted. Another couple of questions that came up. That's pretty good. Thank you, Daljit, for responding to the one from about EDB failover. For everybody's benefit, the question was, does this also work for EDB with failover manager, EFM? And the answer is yes, it works. So we support EDB with Patroni and etcd. So that's the HA solution pathway over there. There was another question about which database management systems are supported. That's actually a really good question. Let me flash that slide quickly once again for everybody's benefit. So this is the list of databases that we support today. Again, Mongo, Maria, EDB, and Postgres. Oracle, MySQL, and SQL Server. All of these are supported in relatively similar levels. The one sort of distinction I'd like to call out, obviously, each database engine is different from the other. So, for example, some database engines will have pieces of functionality that only exist there and do not commute very well from a higher level of abstraction. But one thing I wanted to call out, especially given today's topic about high availability, you can provision highly available database clusters, especially with starting from the 2.9 release, which is coming up next week, for all of these databases except for MariaDB, which is currently limited to a single instance provisioning workflow. Supporting HA for Maria is on our backlog, so if that's something that is interesting to you, please do reach out to your account teams, and we'd love to help prioritize and schedule that work appropriately from our backlog. Other than that, all the rest of the databases do support HA provisioning. Right now in 2.9, the additional HA provisioning support that's coming in is for MySQL HA via the API and CLI only initially, followed up with a fast follow for UI support shortly after 2.9 as well, hopefully. So again, these are the database engines that we support, to answer that question. There is another question about if there are any plans to support stretched rack for Oracle. We were told the data guard deployment would be available. Yes, okay, very good. So let me address that. So for Oracle, today we support rack, and so we support different rack configurations. As of it's been supported for several releases actually. Starting with 2.9, which again you should be seeing as soon as next week. We're also shipping support for data guard. So you will get that functionality in 2.9. It'll be supported via API, CLI, as well as the UI to answer that question. And there's a broad set of data guard features that are expected to come in at the time. Again, this is the data guard support functionality is geared overwhelmingly for disaster recovery scenarios, more so than HA scenarios. But since the question was brought up, I'll address that very quickly. There's a lot of data guard features supported. So for example, you can basically pick your replication mode between max protection, max availability, and max performance. You can deploy a cascaded topology as well as multiple standbys. The one feature that is not coming into this release is fast start failover. In case somebody wanted to use DataGuard FSFO for HA, that's not happening yet. So again, we're still relying on RAC for HA support. However, FSFO support is also on our backlog, so expect that to show up as well soon. All right, more questions. Does SQL Server licensing differ? Interesting. Okay. Yeah, that's a very good question. I think it's a little bit more detailed than we can get to in this call. So again, please reach out to the account team to figure out how that works. You can basically there's smart ways of leveraging licensing effectively with your deployment solutions here. But I would recommend we follow that up like more in a more detailed manner, because A, I don't have all the details, and B, it's not a straightforward conversation for this forum. Right, there's more questions. One second. Okay, I think we addressed these. We want to see more on SQL Server and the benefits of using NDB. Right. Okay, so Daljit, by the way, we're getting, I think, a significant amount of interest in maybe having a SQL-specific deep dive. I think are folks interested in just the HA scenarios, or overall just a SQL deep dive across all SQL features? I'm hearing a lot of SQL in the comments. So I can't pull up a poll right now, but if you're, yeah, okay. Yeah, that's what I was looking for. So please do send that request in the chat, and we'd be happy to organize that. I'll reach out to my SQL counterpart from the product team, and I'm totally expecting there's going to be a lot of interest in SQL. Okay, native features of NDB which help the HA capabilities offered by Nutanix and not natively by the database engines themselves. Perfect. Okay, that's a really good question. Let me explain to people more background there. And I think, how are we doing on time? We're doing pretty well. Okay, we can probably take this one and maybe another one if we're lucky. Okay, so this is a very good question. As I have alluded to in the talk today, and if you've been following the Tech Talk series, you've probably seen a lot of strong references to the underlying Nutanix stack, which has many disaster recovery features and resiliency features baked in to the Nutanix stack itself. Now, interestingly enough, some of these features, like I showed you the replication factor conversation today, that accrues very easily and very neatly within NDB. But other parts of deeper into the stack do not work as well as you'd expect for NDB, specifically from a database perspective. So yes, that is true, and there's a reason for that, and there's a backlog, associated with how we're going to react to that. So in a nutshell, it has the reason why we are prioritizing native database engine resiliency features for NDB rather than the underlying storage stack has to do with something that we basically covered earlier in this talk, which is the fact that the database engine is the most is the closest actor that is most intimately aware of what transaction details are. So basically, whenever you're conducting a transaction, your database engine has the best appreciation and understanding of what the boundaries of that transaction are, and consequently, it is able to give you the best application consistent and transaction consistent levels of resiliency and recovery that you can get for a database workload. And in many cases, that's the number one priority that we've been hearing from the field. People using database workloads will require application level consistency so that they can extend that service to their customers. Having said that, again, it's not a blanket statement, and it depends on your, the tiers of criticality of your business application. And we absolutely hear the demand for other non-native database engine based recovery and resiliency options, such as, for example, getting infrastructure level support for your database recovery. So yes, we hear that request, and it is actively on our backlog, and it's something we're prioritizing. We look forward to sort of continuing to work with everybody who has that requirement. Again, please register this sort of dependency or requirement with your account team. It helps us with the backlog prioritization. But suffice it to say, for the time being, that I hear you. We're aware of this, and it is something I'm personally actively pushing for prioritization on our backlog, because I think we're at a stage where we have a sufficient portfolio of support for native database functionality, which is obviously the gold standard, to go beyond that and then start offering infrastructure level or underlying Nutanix stack level resiliency support. One of the advantages that people cite for this, even though it is not as responsive or resilient as a native database engine approach, is because it allows IT and DevOps and administration teams to use a uniform disaster recovery set of solutions or suite of tooling across the board, so that they don't have to bifurcate one solution for a specific workload and then dive deep into databases for another workload. So it absolutely makes sense, and we'd love to continue working on prioritizing with everybody. And I completely agreed that that's a priority. Hopefully that's addressed that question. I'm not seeing any additional questions, which is actually a very fortuitous event, because I think we're almost at time. Yep. Okay, so I think let's get ready to wrap it up. Daljit, would you like to share any parting comments, or are you good?
No, I'm good, Mohammed.
Perfect. Okay. Folks, we were very happy to have you online with us today, and we will be posting the recording link as soon as it's processed. And again, really happy to have you join these Tech Talks. Please continue to join us for future sessions, and let us know other topics you want us to cover. We have a pretty exciting lineup of topics already planned, but your feedback makes it all the more compelling. And we're just very happy to have these conversations with you and your engagement in the questions. Thank you once again on behalf of myself and Daljit, and we look forward to seeing you guys the next time. Bye for now.
Thank you, everyone.